Hi, this is Mr. Estrada. Today we are going to go over number 35 from the June 2012 geometry Regents. Given AD bisects BC at E, AB is perpendicular to BC, DC is perpendicular to BC, prove AB is congruent to DC. Okay, so in this proof, we are being asked to prove that AB is perpendicular to DC. Now, as you can see, AB is a part of this triangle here, and CD is a part of this triangle here. So the way we are going to prove that AB is congruent to DC is by proving that the triangles are congruent. Because if the triangles are congruent, then it only makes sense that the corresponding parts are congruent. And that's what we call CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. So essentially what we're going to say is, look, AB has to be equal to DC because triangle AEB and triangle DEC are congruent. And if the triangles are congruent, then the corresponding parts are congruent. So we know that we're going to be using CPCTC here. That's how we're going to prove AB is congruent to DC. But before we actually use CPCTC, we have to prove that the triangles are indeed congruent. So that's what we are going to do first. Okay, so let's prove that these triangles are congruent. So here's what we know. We know that AB is perpendicular to BC, DC is perpendicular to BC. So what that means is angle B is 90 degrees and angle C is also 90 degrees because perpendicular lines make 90-degree angles. So angle B and C are right angles. And the reason is perpendicular lines form right angles, right? AB is perpendicular to BC, so this is 90. DC is perpendicular to BC, so this is 90. Now, since they're both 90 degrees, that means that they're equal or they're congruent because all right angles are congruent. Next, we were told that line AD bisects BC at E. So if line BC is being bisected at E, that means that BE is congruent to EC. So let's go ahead and write that. BE is congruent to EC, and the reason is line AD bisects BC. Okay, that's the definition of a bisector. It's going to cut a line at the midpoint, creating two equal segments. Okay, next, we can also say that these angles here are equal. Angle AEB and angle DEC. We can say that because they're vertical angles, and vertical angles are congruent. Okay, now we have enough here to say that the triangles are congruent. We can say triangle AEB is congruent to triangle DEC. And what we're going to say is they're congruent because of the angle side angle congruent to the angle side angle postulate. And then finally, remember, our ultimate goal was not to prove that triangles are congruent. That was part of our goal. Our ultimate goal was to prove that AB, a part of this triangle, and DC, a part of this triangle, are congruent to each other. We can say that now. Now we can say that AB is congruent to DC because corresponding parts of congruent triangles are congruent, right? It only makes sense that AB is equal to DC because the triangles are congruent. And if the triangles are congruent, then the corresponding parts are congruent. Okay? Thank you very much for your time. I hope that that was helpful. If you have any questions, write me comments at my website. Take care.